Welcome to the Cannabis Connection. I am your host, Christopher Carr. Tonight, our guest is Dr. Elaine Ingham. She is an American soil biology researcher and founder of Soil Web Incorporated. We're going to be learning a lot about soil science and building living soils. We want to explore the idea of utilizing nature and essentially leaving nature to do the work for us in stewarding all plants, but specifically we're going to talk about cultivating cannabis on this fine spring Friday, May 20th. Welcome to the Cannabis Connection.
Hello.
Hello.
Hi.
We connected.
Yes, made it.
We made it. I'm so happy to hear from you. Thank you for joining us.
Yes, glad to be here.
Well, great. So let's maybe just start with a little bit of background about yourself. I know you graduated from Colorado University.
Colorado State University. That's where I earned my PhD. So started working with soil biology when I was doing my master's degree at Texas A&M, and then continued that at Colorado State University with my PhD there. Then I moved to the University of Georgia and worked in those ecosystems, so at each place along the way, gaining experience with the different kinds of plants and the agricultural practices in each of those parts of the country. So from the University of Georgia, went to Oregon State University as an assistant professor, associate professor, and in 1996 started my own company called Soil Food Web Incorporated, and I've been running that company ever since. So doing a lot of work, traveling around the world, growing plants in all kinds of different habitats and climates, and getting a pretty good tour of most of the different ways that people try to grow plants, and learning that really the conventional agricultural practices that we use now are really very inappropriate. We're destroying the very resource that we have to have in order to grow plants that are healthy and maintain human health.
And what was the, microbes back in the day when you were getting your PhD, they were acknowledged, but was it as valued as it is now today with our exploration with the building living soils? Were they able to understand the value of these biology and these microbes?
Not at all. They were pretty clueless. I remember when I was taking introductory soil science, and the book that we were using, Brady's third edition, Introduction to Soil, there was basically one paragraph, one sentence really, with any information about soil organisms, and the statement that was made in that book, along about the third paragraph in the book, was that microorganisms are very important. Mm-hmm. And that's it. After that, they went into how inorganic fertilizers move through soil carried by water, and talked about how to calculate how much inorganic nitrogen needed to go into the soil, and how much lime and how much gypsum, and all these inorganic fertilizers, which are basically salts, mm-hmm. and which kill the biology in the soil. The microorganisms, the beneficial organisms that actually help plants grow, will be killed by those inorganic fertilizers, so that you, as a grower, as a farmer, you become totally dependent, and perhaps the better word is addicted, mm-hmm. to those inorganic fertilizers, because you've killed off the very organisms that do the work that nature intended to cycle nutrients into plant-available forms. You kill those organisms off with inorganic fertilizers, and you end up having to use the inorganic fertilizers. It's quite a racket if you think about it from the point of view of fertilizer salesmen. Mm-hmm. They're making sure that you have to come back and buy more of their product. And as you destroy that natural nutrient cycling system in the soil, your plants can't get the nutrients that they need, so your plants are sick, they're unhealthy, They're very susceptible to insect attack, to any kind of diseases. They can't protect their root systems. They can't protect the foliage. They can't protect the buds, the fruit of the plant. And so we think then that we have to put on pesticides in order to prevent the diseases and pests and problem organisms from attacking our plants, which would not be happening at all if we just kept the biology, the proper sets of beneficial organisms in our soils. We wouldn't have those insect, pest, disease problems. There's couple more really important things that this biology in the soil does for your plant, which is to build structure in the soil so that you have the airways and passageways, the hallways to allow oxygen and water to move into the soil. If you have good structure, water infiltrates and goes down deeper into the soil where the roots can follow along. As long as there's good structure in the soil, roots can go as deep as they can go based on the physiology of the plant. And so they will follow the air passageways, the hallways, the spaces to get to that water. And you won't have to irrigate. You won't have to use as much water to keep your plants alive through a dry summer period. So we don't have drought problems. We don't have those limitations. We use, for example, when we've been doing this work in South Africa, in Arizona, New Mexico, in the very dry parts of the world, we can reduce water use by as much as 70%.
Holy. That's
if we get the
significant.
biology back into the soil. Yeah.
Yeah, and look, can we explore how plants are mutualists? So the plant and the healthy harvest is almost a symptom of the soil, and there's this symbiotic relationship that the plants share with all of the biology within the soil, and how the plants essentially feed the biology, and then consequently those biology feed the root system, or essentially they make the nutrients readily available for the plant.
Yep, and it's something that we really have to understand if we're going to make this work in our plant growing system. So basically the biology that's present in the soil needs to be well dispersed, well spread within that soil, so when the roots start growing into the soil and the plant starts to release exudates, which is a really cute scientific term, and most people go, exudate, what does that mean? Because it's scientific-ese, and we scientists maintain our superiority over non-scientists by
jargon,
jargon, just like any other profession. We got to have our secret language.
Yes.
So an exudate is simply proteins, sugars, and carbohydrates, mostly simple sugars from photosynthesis, and a few proteins, a few carbohydrates. And again, it adds a little bit of jargon as well, because what are those things? If I sent you into your kitchen and I asked you to make a recipe of mostly simple sugar, a little bit of protein, and a little bit of carbohydrate, most people go, what is she talking about? So let's turn that into English, everyday English. So sugar in your kitchen is white sugar, brown sugar, honey, molasses, all those wonderful sweet things that we use to cook, to make basic recipes. So I'll take your bowl and put a little bit of each of those things, or vary the recipe a little bit, and you can think of all the different recipes you can start to make when we do different amounts and different combinations of those simple sugars. Proteins in your kitchen would be things like eggs and milk, those things that we're going to add into our bowl. And now finally we're going to use carbohydrates. And carbohydrate in your kitchen is mostly flour. So when you think about this recipe, the exudates coming out of the plants, they are made up of sugars, eggs, milk, and flour, which is a recipe for all the many different cakes and cookies that we make. Think of all the different kinds of, donuts and cakes and cookies and all those wonderful things that we like to eat, which make us fat, are being released from that root system. So the plant has a lot at its command when it puts out this kind of tea cake, or it puts out Christmas cookies, or it puts out chocolate chips, or oatmeal raisins, or it puts out lemon meringue pie, or apple pie, or all the different kinds of cakes and cookies that could be released. The plant is doing that to get specific species of bacteria and fungi to grow so that those bacteria and fungi will do jobs that the plant requires.
Mm-hmm.
So the exudates are specifically put out to tell the right sets of bacteria and fungi to make enzymes, go out and use those enzymes to pull the nutrients out of the sand, the silt, the clay, the rocks, the pebbles, the boulders, the parent material, and, of course, organic matter, whatever might happen to be out there, so that those bacteria and fungi will take all of the nutrients that the plant's going to need in the proper balance and tie those nutrients up in the bacterial and fungal biomass. So it's like the plant is putting together the pantry, the larder, where it's storing all the nutrients it's going to need through the growing season. And then because the bacteria and fungi are growing to really high numbers around that root system, it attracts in the protozoa, the nematodes, the microarthropods, the earthworms, all those organisms in the soil that eat bacteria and fungi. But because the nutrient concentration of all the different kinds of nutrients your plant requires are much higher in the bacteria and fungi, because all those great exudates, the cakes and cookies the plant gave those bacteria and fungi, the concentration of nutrients in the bacteria and fungi are much, much higher than what the predators, the protozoa, nematodes, microarthropods, earthworms, much higher than what they need. Mm. So whenever a bacterium or a fungus gets eaten by one of its predators, the predator is going to release all that excess nutrients, not just nitrogen, not just phosphorus, not just sulfur, all of the nutrients in the proper balances right there at the root surface.
For the plant.
So the plant just takes up what it needs. The plant doesn't have to expend a lot of energy setting up diffusion gradients and pulling nitrogen and phosphorus in from feet and, meters or yards away from that root system. The plant is handed exactly what it needs through this predator-prey interaction. It's, when people think about agricultural systems and how we always talk, the soil scientists always talk about how plants pull all the nutrients out of the soil and there's nothing left, so we have to put on these inorganic fertilizers. So how do you explain an old-growth forest?
Yeah, there you go.
Since, look at the redwoods here in California. They have been growing in the same place for, since before Christ walked the planet. Mm-hmm. They've been there pulling nutrients out of the soil. So how can they still be alive if nobody's putting out inorganic fertilizers and keeping those plants alive and putting out pesticides to keep those plants from being destroyed by pests and diseases and things? How is it that Mother Nature manages to keep forests alive for thousands of years? How do beautiful pastures manage to survive for 12,000 years in the Great Plains of the United States? How can that be if you can only grow these plants very rapidly in highly productive systems if you're putting on inorganic fertilizers and pesticides? It just makes no sense. Mm-hmm. So nature has to have this way of growing plants. There's got to be a mechanism, and that's what we were just talking about, that Beautiful. Nutrient cycling process where all of the balance of all the nutrients, and that's one of the big problems with conventional agriculture. They concentrate on just nitrogen mm-hmm. or just phosphorus or just potassium. How many different types of nutrients does a plant actually need in order to grow in a healthy fashion? So I love it when I go back in time and I think about when I was a kid back in grade school, and, how many essential nutrients were there then? Nitrogen, and that was it. Well, and then we figured out that, plants don't grow by nitrogen alone. So then it became NPK. 3.
Yeah, there you go.
Yep.
We have a caller here. I just want to see if they have something to comment on this. This is a lot of really important information. And Richard from Carmel, you're on the Cannabis Connection.
Hi, good evening. First of all, you sound incredibly intelligent, and I'm sure you are. Just by listening to you, you know a lot. I'm sorry I didn't catch your name, not to be unpolite, but I didn't hear it.
Yeah, her name's Dr. Elaine Ingham.
Dr. Ingham. Two things. It's interesting that so little emphasis is put on micronutrients when it comes to cannabis. Since this is the cannabis kind of connection here, I'm going to refer to cannabis. Of course, it's in other plants as well. But you don't hear much about micronutrients, and I'd like you to talk about that if you don't mind. And also, don't take this wrong, but I'm an I'm in my 60s, old-time pot grower from years back, what you call guerrilla grower. And you know as well as I do, when a person has 100 plants or 1,000 plants out there, they have to use things like fungicides and pesticides. And I always use things that were vegetable healthy, in other words, human healthy, if it could be eaten by humans, and I felt it was safe to use. And then, of course, I flushed for a couple of weeks before ever harvesting. But my complaint is all these dispensaries, they talk about testing, but I never see any testing. I haven't seen it yet on any of them for fungicides or pesticides. And it's like, why aren't folks like you demanding that these places do that test? Because it's so important, I think. Or am I wrong?
Yeah, go ahead.
Yeah, you're exactly right. That the recent work that's been done with glyphosate or Roundup, the trade name for that particular herbicide.
Yes.
What they're showing is that glyphosate is showing up, Roundup is showing up in many, many different kinds of foods. For example, any conventionally grown wine grapes have a very high concentration of glyphosate in the wine.
Wow.
And we're drinking it.
So especially
it is
in California.
Yeah.
Sure.
Yeah. And so it's critically important that consumers understand that they do need to be asking that kind of testing be done. Glyphosate is just one example. And it's because who's in control of most of our university systems?
Well, that was my question. Who's controlling these? You know that since the cannabis thing came on board, immediately these testing laboratories popped up, and I'm just kind of curious. Why are they controlling it in such a way that they're not testing for herbicides and pesticides on the product? When, of course, you know as well as I do, a simple flush for a couple of weeks, I think, you know much better than I, could eliminate a lot of that. But it's all about the money, you know as well as I do. It's not like
bingo,
the good old
you put your finger on it right there. The money.
It's an expensive process for fungicide and pesticide. I mean, a simple potency test, it's a fraction of a cost when it comes to the complete rigorous testing that you're asking for. Typically, when there's a big event in which where there's a cup and cannabis is being evaluated to compete, they test. Like a good example is the Emerald Cup. And for years it's been just a potency test, but now they're getting to a point where we're getting closer to being regulated by the state and different local jurisdictions taking up licensing and regulating the medicine. And so to your point, the future is in fungicide and pesticide and complete rigorous testing. And so it is though. The bottom line is it's very expensive for each sample to get tested.
I'm going to disagree with you a bit here because there is no reason to be using those pesticides or herbicides or inorganic fertilizers. Your plants don't need them. If you get the proper biology back into the soil and you are not stressing your plant in any way by nutrient limitation, if the microorganisms in the soil and that natural nutrient cycling are happening at a rate directed by the plant's in control of its own life, then it's never stressed. If a plant is not in a stressed mode, it is not susceptible to the pests and the diseases. It will protect itself. And the biggest protectors, the organisms that protect that plant growing on all of the surfaces of the plant, the leaves, the buds, the flowers, the roots, the stalks, the stem, everything should be covered by a really healthy set of bacteria and fungi. And if you do have those appropriate organisms completely covering all parts of your plants, the pests and diseases don't even know the plant's there. There is no signal to attract them to that plant. The plant's not stressed. It's not going to put out the stress signals to say, I'm sick, I'm unhealthy. Mother Nature says, hey, garbage collectors, come in and take care of this diseased plant, this unhealthy plant. And the diseases and pests are just doing what Mother Nature needs them to do, to take out the things that don't contain the nutrients to keep that plant healthy. But we have to put that nutrient cycling system back into the soil. We have to make certain all the microorganisms are present to protect all of the surfaces of those plants every second of every day while that plant is alive. And so because we've been killing those organisms in the soil off with our toxic chemicals, with too much tillage, with the pesticides, the inorganic fertilizers, we're we're really walking down the pathway to hell, aren't we?
That's right.
The path to hell is paved with good intentions. But we have to understand what we've been doing, and we have to reverse course. We've got to come back the other way and follow what Mother Nature has been doing ever since plants appeared on this planet over 1 billion years ago. Mother Nature's been working on this interaction, figuring out how to make it work for 1 billion years. She's had a little practice.
Yep.
How long have we been practicing pesticides, inorganic fertilizers, and inappropriate tillage?
Yeah, just a few decades.
And
it's
laughable that we pretend that we know what we're doing when we're growing plants.
No, exactly. And I want to thank Richard for the call. I just wanted to keep going there. So thank you, Richard, for your call, and it was really nice to hear from you. And with that, let's take a quick break. We're at the bottom of the hour. You're listening to the Cannabis Connection.
The Cannabis Connection is brought to you by Kind People's Collective. Quickly becoming a community epicenter for local art, culture, and cannabis, Kind People's Collective is creating a new standard for alternative medicine. The staff at Kind People's Collective provides professional and well-informed guidance to help patients understand how cannabis may best suit their needs. Come experience Santa Cruz's state-of-the-art facility located at 3600 Soquel Avenue at the corner of 17th Ave and Soquel Frontage Road. Please visit our website at kindpeoples.org for all things cannabis related. Get informed, get relief.
Welcome back to the Cannabis Connection. I want to give a shout out to our newest sponsor, Global Garden Supply. They have hydroponics equipment, used equipment, compost tea, which we'll get into a little bit more in the program. They're located at 1655 38th Avenue in Capitola. You can reach them at 831-854-7890. These guys are excellent resources for anyone interested in gardening or cultivation or farming of any kind, especially when it comes to your cannabis needs. And they have free compost tea Monday and Sunday while supplies last. Check them out. And we're back. So one thing I did want to cover tonight is, what is the first step someone can take in order to shift away from conventional growing with chemical amendments to biological growing?
You really need to return the full food web back to the soil that your plant is growing in, and you want to be applying the full set of organisms to the above ground parts of your plant as well. You've got to get that protective layer back around, surrounding all of that plant. And once that protective layer is there, then of course the plant's putting out the exudates and all this nutrient cycling. And as Richard asked before we took the break, he was asking about, micronutrients, and that so many places pay no attention to the micronutrients, but they're critically important, especially when we're talking about concentrations of things like THC, or when we're talking about cannabinoids. I always have problems saying that word.
Cannabinoids, yeah.
That's it.
There you go.
and all of those specific kinds of compounds that we want to make certain are in the plant that we're trying to grow. What kind of product are you thinking about? And you've got to have the proper balances of the micronutrients to have those compounds made and be present in the concentrations that cultivar is capable of producing. When we're concentrating just on a few inorganic nutrients, we're missing the boat. We are not getting the production that we require or would like to have in the plants that we're growing. So micronutrients are critically important. And the way to make certain that your plant is getting all of those micronutrients, that the flavor, the taste, the components that you want are present, you have to have this natural nutrient cycling going on around the root system, because all of the micronutrients, as well as the macronutrients, are being supplied to that plant, and the plant is in control of telling the microorganisms in the root system precisely what it wants. Hey, you guys, get to work down there. And off it goes. So our job as growers is just to make sure that all of those organisms are actually present in the soil surrounding the plant.
And what are some best ways to build biodiversity in living soil?
The best way to do it is to get all these organisms back into your soil is to make your own compost.
Nice.
Then it's local. You're getting all the indigenous local organisms that are adapted to the climate, to the conditions, so that you're going to put on the protective layer on your plant that is used to protecting plants under these conditions. Your microclimates, your places. Do not be buying compost from Southern California if you live in Northern California, because it's not the right set of organisms that you're going to be obtaining. You need something that tolerates and is has the experience of growing under the conditions of Northern California and not desert Southwest or something like that. So the easiest way to get the biology on the above ground part of the plant is to apply a compost tea. And the reason making tea is really important is you're going to use the movement of the water by the air pump that you're using to move the water around will extract all of these wonderful organisms that you grow in your compost, pull it into the water, and then you'll add a few foods to help these local indigenous organisms grow to really high numbers. So then you take the compost tea. It has to stay aerobic because the beneficial organisms are all aerobic, because they have to live where there's plenty of oxygen. They don't, on leaf surfaces, on root surfaces, those are aerobic environments. You go anaerobic, you'll kill your plant. So we have to maintain our compost in an aerobic fashion, our compost teas in an aerobic fashion. The organisms in the tea have to be growing very rapidly, because that's when they make the glues to stick themselves onto surfaces. When you think about water moving through compost or water moving through the soil, the microorganisms have to make glues to hold themselves on the surfaces of the organic matter, on the surfaces of the sand, the silt, the clay, the roots. Or as water moves by, those microorganisms would be washed away from their source of food. So we need to have those glues made, and that is done by making sure the organisms are growing very rapidly, putting in proper kinds of foods to grow those organisms. Typically, the thing that is most lacking in our soils are the fungi, the beneficial fungi. We got the bacteria in our soil. We don't have to really be working on improving that because our tillage methods typically select for those bacteria and against the fungi, against the protozoa, against the nematodes. They slice and dice our tillage methods slice and dice and crush those organisms, leaving behind just a bacterial-dominated soil, which, of course, selects for the growth of weeds instead of the plant that we want. So why do we have so much weed problems in conventional agriculture or even in organic agriculture? Because we till the living daylights out of that soil. We till our soil until it's dirt, not soil. Soil has to have living organisms and organic matter. Dirt, no living organisms. So, of course, your plant's going to be susceptible to diseases and pests. So we have to stop tilling in such a crazy manner. And people always then say to me, well, then how are you going to have a good seed bed? How can you plant your seeds in there, plant your starts in there, and the roots can find their way through the soil, or the seed can germinate and grow out of that soil? It's going to be terribly compacted. Well, that's the job of the microorganisms. They build the structure in the soil. Tillage doesn't build structure. Tillage imposes some fluff until the first time it rains or until the first time you irrigate. And compaction starts to occur immediately. There's nothing to build structure in the soil if you don't have these microorganisms doing their jobs at the direction of the plant to build that structure so the oxygen can get to that root system. So putting compost tea on the foliage, on the above ground part of the plant, so all these wonderful microorganisms will immediately, instantly stick to the surface of the plant, to the leaves, the top part of the leaf, the bottom side of the leaf, which bottom side of the leaf is the most important because that's where the diseases and the pests attack first. It's a protected environment. Got to get these organisms on the bottom of the leaf, on the stems, on the branches, on the stalks of your plants. And then for your soil, you would want to put on a compost extract into the soil because the organisms moving into the soil need to find the various habitats that they're best suited to, and then they'll start growing and making the glues. The plant is putting out the exudates. Plants put exudates out in the foliage, in the above-ground part of the plant, as well in the root system. So getting those organisms close to the plant. Soak your seed, for example, in a really good compost extract or a compost tea so that all around and through, under the seed coat, in the cracks and crevices of the seed, you have the organisms. And so as soon as that seed germinates and the roots start going down into the soil, the cotyledons move up above the ground, we want all of those surfaces covered with this really good biology. And this is the way we will make certain that those organisms, that inoculum, is present in your soil. So good compost tea, put compost in furrow, or if you don't have enough compost, to actually put the compost in furrow just as you drop your seed or just as you put your starts in. Then you'll want to be putting a compost extract or compost tea into that furrow so the biology your plant needs so it can be healthy, won't be diseased, it won't be stressed for water, it won't be stressed for nutrients, and you won't have weed problems. So that's the way to get it.
Brilliant. And when we get it to the underside of the leaf, so are we talking about like a foliar spray with the compost tea?
Yep, the compost tea is the foliar spray because in the compost tea, the organisms are growing really fast, and they're making those glues. So the glue protects the microorganisms from ultraviolet, so they're not killed by flying through the air. So they're protected inside that drop, and then they'll stick instantly to the leaf surface, the branch, the bud, the flower, all parts of the plant very rapidly.
And it's almost like a protective layer, so those small beasties are just working that symbiotic relationship even on the foliar, underside of the leaf. It's just like the roots. It's a similar exchange.
Yep. The plant's putting out exudates, telling those bacteria and fungi what the plant requires. And I think part of the conversation above ground is the plant's putting out the skin protectant, like we put out SPF anti-UV.
Sure.
The plant's putting out its own exudates to grow those bacteria and fungi to protect it from the diseases, pests, the problem organisms, protect it from having to respire so much water. It's a protective layer. It's sunscreen for your plant.
And it's case in point why you don't need pesticides, because you have natural preventative. Again, how can we outsmart nature when she's been doing this for millennia and knows what to do? There's nothing better than leaving nature as our model and just being there to steward and essentially leave it alone is what I'm learning.
Yep. We need to let Mother Nature do what Mother Nature has always done. If we start fighting Mother Nature, who's going to win that battle? Who's going to win that war?
Yeah, Mother Nature.
It's not us
always.
as human beings, it's her.
Yeah.
Nature is not going to be happy with us, and if nature gets really unhappy with you, you aren't going to be here anymore.
Well, and that's something to think about, like the greater picture of this. I think it's really nice to think about the paradigm shift in our laws and in our society around cannabis. I see cannabis as a catalyst for raising consciousness around the world about a symbiotic relationship that humanity can rediscover with plants. And through learning about cannabis, we can also learn about the environment. And my question is, how can living soil save the world?
Well, because we will stop destroying water quality. We will stop destroying soil. We will build the resources. We will be able to take something that we've been turning into deserts and turning it back into productive land, beautiful pastures, beautiful forests, beautiful agricultural areas once again, instead of just leaving a path, a trail of destruction behind us. So we have to follow this direction if we want to really, truly feed the world. And I always, Monsanto always says, we're going to run out of food in 2025, so we have to do the genetic engineered organism thing. Sorry, it's not food that's going to kill the human beings on this planet. It's not the lack of things to eat, it's the lack of water. The lack of clean water is already a serious problem in all parts of the world. There are water wars that are going on already in third world countries. And, take a look at Flint, Michigan, and that's just the barest tip of that particular iceberg. It's like every place in the Midwest of the United States, they all have heavy metal problems, toxic chemicals. You can't drink water from any well in the state of Iowa because it's all contaminated with atrazine, herbicide, with glyphosate, with nitrate fertilizers, and it's spreading across the U.S. We are destroying clean water. How do we fix that? We have to stop putting on the toxic chemicals. We have to stop using the pesticides, and we've got to put this biology back into the soil, which can decompose all those toxic materials, pull that back in and put it into a complex organic structure within the soil that is not going to be released any time in the near future. Half-life of 500 to 1,000 years. So it's slowly, those toxins are broken up, slowly dispersed into their component chemical formulations and no longer destroying water quality. Well, we got to do the same thing for soil because we've been destroying that. Have to start working with nature instead of against her.
Mm. One thing I was just reliving in my mind, too, is you said aerating the compost tea with the air pump. For building compost, like on a property or on a farm, maybe you can just share, like a standard operating procedure for that. Is it a manual aeration where we're out there with a pitchfork kind of turning things and watering to keep the biology alive? Because I know as the biology dry out, it's almost like their shells their outer layers are kind of dehydrating, making it harder. So you have to kind of work that water and work that air into the compost.
Yeah, you've got to think of these organisms in the soil or in the compost as being just like little tiny human beings. Yeah. They have a set of requirements. Yeah. Well, if you don't have enough water to drink on a daily basis, what happens to you? You turn into a mummy. We're going to get a lot of productivity out of you when that happens. Same thing for the microorganisms. You can't let that compost pile dry down less than about 40% moisture is, you don't want to go any lower than that. And then people always go, well, how am I going to measure moisture? I'm going to have special little pans, and I'm going to have to weigh them, and I got to put them in my oven at night, and I got to remember to take them out. Oh my gosh, it's so much work. No, you just take your hand. There's the simple instrument that you can use to dig down into your compost pile and just grab enough of that compost material to fit in your hand comfortably, and then you squeeze it. The proper moisture for a compost pile is where when you squeeze that material, you can just express a couple drops of water, or I don't have a really strong grip, so I just see a little bit of moisture coming between my fingers. Okay. That's 50% moisture. That's what you want to maintain your compost pile at all times during the composting process. If you pick up some of that material and you squeeze it, no water comes out, then you want to open up your hand. If when you open up your hand, all of that material sticks together and, pretty compacted or, pretty tight balls, stuff doesn't fall apart, you're at about 45% moisture. When you're open up your hand and all that material starts to fall apart, flakes off, it's not holding together, then you're getting down a little bit dry. Your microorganisms aren't going to like you anymore, and they're not going to work for you. So you want to maintain that moisture above 40%. When it's too dry, the material starts falling apart in your hand. You're below 40%. You're gonna want to turn your pile and be spritzing in moisture, just your hose, and spritz it lightly as you're turning it. When you're composting, in order to kill the human pathogens, the plant pathogens, the root-feeding nematodes, the weed seeds, all the problems that we don't want to have in that compost pile, we need to make sure that the temperature is getting above the proper temperature for at least 10 days. So typically we want to see the temperature starting at ambient, and it should increase because of the growth of the bacteria and the fungi, the protozoa and the nematodes in that compost pile. That's what's generating the temperature. That's what causes it to heat up. So, I always say to people, reproduction is what these microorganisms are doing. And think about yourself as a human being. When you perform reproductive acts, is there a little heat that's going to be generated?
Oh, yeah.
Yep, and that's
right.
exactly what's happening when the microorganisms are reproducing. So the faster they go, the more temperature, right. And as they are doing all this work and having all this great time in that compost pile, also using up oxygen. So when the temperature of that pile hits about 160, 165, the oxygen is being all used up through all these wonderful reproductive acts that the bacteria and fungi are doing, growing on the food that you've put into the pile. And so you just need to turn the pile to get the oxygen back into the pile, to cool it down a little bit, and the microorganisms take off again. You typically want to be turning the pile at least 5 times during the first 10 to 15 days that you're doing the thermal composting. And if you're doing that, maintaining really good oxygen and keeping it moist, you are going to kill all the pathogens, all the disease-causing organisms, all the root-feeding nematodes, all the insect larvae that you don't want to have in there. All the weed seeds are going to be killed. So making compost properly is really critical. Plus, you're growing all the best organisms. And there's your protective layer. There's your nutrient cycling committee. There's all the building soil structure engineers that your plant requires. And it all comes in one package. Isn't nature clever? The way he's put all this together is just so simply beautiful.
Yeah, it's really... Yeah, it's perfect to think that here comes Monsanto with Roundup trying to dominate nature, and then what you just described to me is just case in point. There's no need for any of that poison, because if you just let nature rock what, this beautiful reproductive microbe soiree in the compost pile, I think that's definitely a case in point where it's a new direction, but the new direction is actually the oldest direction there is in the book, which is just going back to
the way nature's been doing for the last billion years.
Just let the microbes do the birds and the bees thing in the compost pile, and you've got the full arsenal to set your grow up for success. And it's a regenerative process. It's something that is going to continue to grow and continue to turn that dirt that Monsanto, adulterated from living soil to dust and reinvigorate it with all of this life and heat and microbe culture. You got this bustling metropolis of symbiotic reactions happening and so much life, growing life. It is truly an inspiration, and we're getting towards the end of the program here, so I do want to take another call. This is Bob from Oregon. Welcome. You're on the Cannabis Connection.
Hey, guys. How's it going?
Doing well. Hey, Bob.
Excellent. Well, I was just calling in because I'm a huge fan of Dr. Ingham's work and the living soil, the probiotics and everything, and I guess I just wanted to pose one question and make one quick statement. I recently started reading about what's known as Korean natural farming, thanks to some really inspirational people through Instagram, believe it or not. And I started collecting what's called indigenous microorganisms. And I just wanted to throw out there for everyone listening, because this has been a really kind of quick process for me, but it's literally changing everything. And I just wondered if maybe she could give a few people out there that might want, tips on how to harvest microbes. Just because, being used to spending so much money on these microbial products from made in laboratories and all these other things, from now just going out around my environment and harvesting these microbes out of soil and the slurries from my teas, it started to just change everything. And so that also leads me to my question for her, which is just in studying these Korean farming applications from Dr. Cho, he talks about anaerobic bacteria, and that actually the air is working against the propagation of a lot of the anaerobic bacteria we need to break down organic materials. So anyway, I just wanted to put that out there and see if she could maybe talk a little bit about that and maybe give people tips on how to actually cultivate microorganisms outside of the heat.
Thank you, Bob.
There's no reason to go out and buy inocula of these microorganisms, because they're already in your environment. When you're making a compost pile, you're going to get legumes for the high nitrogen, or perhaps manure if you want to go that direction, and that comes with a boatload of all these organisms in it. Yeah, the manure is going to have some anaerobic organisms in it, but the legumes will all have aerobic organisms. Then you need green plant material, and that's coming with a whole bunch of different microorganisms on it. When you collect your woody materials, that has another whole different set of microorganisms. So collect the organisms from your environment. You go into the nursery and to the box stores, or wherever you're buying these inocula from, and where did they isolate those organisms from? It's probably not your environment, not the climate, not the habitat that you live in. And you've got to get the indigenous organisms that are used to and grow and flourish under your environmental conditions. They don't come from St. Louis. They don't come from New York City. So buying inocula, when you go and look at what's on the surface of a rose leaf or a blade of grass that has not been treated with pesticides or inorganic fertilizers, massive numbers of microorganisms. When we look at a gram of healthy soil, there's 75,000 species of bacteria and 25,000 species of fungi and 1,000 different species of protozoa and 100 different species of nematodes in that 1 teaspoon of soil.
Wow.
So go and collect your inoculum from your own habitat, from your own environment. Just remember to try to get as much diversity as you can. Lots of different kinds of food resources, lots of different organisms. I know that there's, one of the things that people suggest is that you take a rice ball and go out and put it in the forest and let it sit out there in the forest for a while. But rice is only one kind of food. You need to have a massive diversity. You want to collect plant material from all the different plants in the forest. A pinch, a tiny leaf, just a little bit of a twig. It all comes with this wonderful set of microorganisms on it. And that is the easiest and cheapest way of collecting that whole diversity of the organisms that you want to see in your compost pile. And you start it off in your compost pile, but after a year, maybe 2, you've put all of this diversity of microorganisms back into your soil. You don't have to keep replenishing it. As long as you do nothing to kill these organisms, they're going to be happy and healthy and hang out. You want a diversity of organisms, of plants in your garden. You don't want to grow just grass. You know, our lawns are some of the most hideous ecosystems on this planet because it's one species of grass. We need flowers. We need short, low-growing, all kinds of different things in our lawns, not just one species of grass. It's like, what, are we trying to ape English nobility, that we've got a lawn with just one species of grass in it? How ugly.
Food, not lawns.
Right, exactly.
Food, not lawns. That's a big deal here in Santa Cruz, and food forests, diversity.
Mm-hmm.
Everything's better when more the merrier.
Exactly. And so when we're talking about anaerobic processes blow off your nitrogen from whatever you've got in that soil as ammonia. Anaerobic processes blow off your phosphorus as phosphine gas. It blows off your sulfur as hydrogen sulfide. You're losing the very nutrients that you need to grow your plant when you follow anaerobic approaches. When you're making food, fermenting food, we as human beings need that because our digestive systems are anaerobic, but the soil is not anaerobic. And we're actually losing those things that we need to grow our plants when we ferment these materials going into our soils. If the compost ferments, if it goes anaerobic, then we are making some really strong acids. And you put a root system into organic material that is strongly acid, has a very low pH, you're going to be killing your plant. You make some very toxic materials. It's only under anaerobic conditions that we make formaldehyde, that we make all kinds of different aldehydes who will basically preserve our root systems. Preserved root systems do nothing to translocate nutrients or water back up into the above-ground part of the plant. The soil is an aerobic environment. The more we can build structure, get the oxygen to move down deep, get the water to move in that soil, infiltrate instead of eroding or running off. No puddling should be seen in any of your agricultural fields or when you're growing hydroponically. We don't want to see water puddling at the surface of it's dirt if you see puddling.
Yeah.
So we want to have all that structure built so it stays aerobic as far down as you possibly can get it. Most cannabis growers have a misconception about how deep the root system of cannabis can grow. The plants should not have their root systems just down, maybe an inch or 2 or 3 into the soil. With cannabis, we ought to be seeing root systems that are going down at least 4 to 7 feet.
Yeah. Oh, yeah.
Feet, not inches.
Yeah.
Feet.
Well, we're right at the end here, and I just wanted to thank you so much. And I think we could continue this conversation for the next 48 hours, but maybe we can try to pick up the conversation sometime very soon. But I just wanted to thank you so much for taking the time and sharing your wealth of knowledge on the Cannabis Connection.
Well, I thank you for the opportunity to share the knowledge, because you can see that this is information we have to get out to everybody on the planet that grows plants.
It's true. And I commend you for your work. And for anyone listening, a great website is Soil Food Web Inc. www.soilfoodweb.com.
Right. Soilfoodweb.com. Thank you very much for having me on.
Thank you, Doctor. We appreciate you.
Yeah, good night.
Good night. And you've been listening to the Cannabis Connection. I am your host, Christopher Carr. Tune in next week, Friday, 8 p.m., and stay up, Santa Cruz, and have a great weekend.
From Capitola to Carmel, Red Hot News Time, AM 1080 KSCO Santa Cruz.